All right. Hello, all. I had quite a few questions about some of the questions you had on homework assignments regarding limits and end behavior. So I wanted to just give you a quick kind of refresher, clarifier, or maybe this is the first time you're hearing this, but just wanted to give you a quick clarification. This is a pretty low level explanation. So if you're somebody who's not in my class who's looking for something more complex, like what you might see in calculus, this probably is not the video for you. But for my Algebra 1 friends who are being asked about limits with the variation functions, we're going to talk about that right now. So first of all, let's just wrap our heads around some of the notation that's being used. So I have a coordinate plane, okay, and the coordinate plane that you know and love. And when I talk about x's, we know that the x-axis is here and that they run in the positive direction this way forever and the negative direction this way forever. So all we are doing now is saying that if this goes forever in the positive direction, we're going to call this infinity. Okay? That this goes out towards infinity forever and ever and ever. Okay? And so going to the right, we would say is x approaching infinity. That's what this symbol is really saying. X is approaching infinity when I go to the right. Okay? Likewise, in this direction, because this is going into negative land forever and ever and ever, we would call this end of the graph negative infinity. Okay? If we extended this forever and ever and ever and ever. Okay? And so going to the left, we say is x approaching negative infinity. Now we don't actually write it this way. We write it as x approaches negative infinity, okay, just so that it's reading correctly, right? But this is what that's really saying. This is a fancy way of saying go to the left. This is a fancy way of saying go to the right. So when you see this, I want you thinking right. And when you see this, I want you thinking left. Okay, so what the questions actually are asking you is, as x goes to infinity or as x goes to negative infinity, meaning as you move to the right or left, what's happening to your y values? And for right now, everything we've looked at is going to do one of three things. It's going to go up forever. It's going to go down forever. Again, we're talking along the y-axis here. Or it's going to come in towards the center. Okay, it's going to come closer and closer to the middle. So going up forever, we call that, and actually let me use a different color for this one, because these are my y's now. When we go up forever, we call that infinity on the y-axis, right? Going up forever is infinity, meaning going down forever, we call negative infinity, okay? And then when you're squeezing inward to the middle of the graph, okay, when your points are getting closer and closer to the middle, that's a value of 0, okay? So the questions are going to say things like, as x approaches infinity, y approaches what? And really, these are your three choices, okay? Infinity, 0, or negative infinity. So let's talk about what some of these actually look like here, okay? I didn't think about the bleed through there. Sorry about that. Yeah, I'll just sketch a quick graph here. So let's look first at just the basic y equals k times x. So just a basic linear equation. Okay. And I am asking the question, when x goes to infinity, where is y going? Okay. Well, what that is saying is as x goes to the right, so as we're going this way on the graph, what's happening to your y values? So the farther out to the right I go, you should see that the y values are going up, right? The y values are getting higher and higher and higher. As I go to the right, the y's are going up. And remember, on the y-axis, we say going up forever is infinity. So I would say, oh, y is going to infinity. Now, what if I asked you when x goes towards negative infinity, what's happening to y? Okay, well, as x goes to negative infinity, that means I'm going to the left. So So that's going this way. Where are my y values going? Well, it looks to me like they're going down forever, right? Looking at where this pink line is heading, right? My y values are getting smaller and smaller. That's toward negative infinity. So my y values are going closer and closer to negative infinity. Okay. Now, I'm not saying they're ever actually going to reach that, because it's not really possible to reach infinity or negative infinity. That's just the direction they're heading. That whole idea about where they're heading, not where they're going to get to, is important when we talk about end behavior. Okay? So let's look at another one. Let's look at the hyperbola. Okay, so you've got one branch there, one branch here. Okay? And so, again, what I'm asking is, as x goes to the right, okay, or as we move to the right on the graph, what's happening to your y values? Where are they going? Well, you'll notice that what's happening here is this line is getting closer and closer and closer to the x-axis. Okay, it's never actually going to get there, but the y values keep getting smaller. These values are going down, but they're not going down forever like this arrow, right? They're just getting closer and closer and closer to that center line, which is 0. Okay, so we would say in this one, as x approaches infinity, y approaches 0. Okay, and in this one, really, when x approaches negative infinity, it's exactly the same thing. When x approaches negative infinity, y also approaches 0, because if you look at going to the left forever, these numbers are actually getting slightly bigger, right? Because this is getting a little higher and a little higher and a little higher. It's still never actually going to hit 0. So if I extend this x-axis out here and I extend my graph, it's going to creep upward. It's getting a little bit bigger and a little bit bigger. It's going to get closer and closer to that line, but it's never going to hit it. So that's why we say it's approaching 0. Okay? Let me show you that one other way that might make sense for some of you, if I can find my calculator. So let's look at just that first one. Sorry, clear that junk out of there. Oh, you can't see that anyway. I'm going to do this one first, the y equals kx, and to put it in my calculator, I can't use k, right? So I'm just going to have to pick a k value. So I'm going to do 3x, let's just say. And there's my picture, right? We already knew what this picture looked like. It's a line. But if I look in my table, when I say, oh, and my table's counting funny. Sorry, I was using this for something else a second ago. Don't worry about what I'm doing right now. Okay. When I say this, when I say x is going to infinity, that means x is getting bigger forever and ever and ever, and I want to know what's happening to my y values. So in my table, me pushing the down arrow is making my x's get bigger and bigger. Look at these numbers. They're getting bigger and bigger and bigger and bigger. And look at what's happening to my y numbers. They're getting bigger and bigger and bigger and bigger. And that's going to continue forever and ever and ever, right? The bigger my x gets, the bigger my y gets. Okay? Now, if I move back, let me start this over. If I get smaller, so if I make my x values go negative, you'll notice my y numbers are getting smaller and smaller and smaller, okay? And there's not going to be a stopping place, right? These are going to get smaller forever, and negative infinity is our way of saying smaller forever. Let's look at our hyperbola here, okay? So again, that would be the equation y equals k over x, okay? So that would be, I don't know, 3 divided by x, let's say. Doesn't matter what our k value is. I'm going to reset my table again. And again, we haven't talked about table settings at all, so don't worry about that. When I look in my table, when my x's get bigger forever, okay, look at what's happening to my y values. They're getting a little smaller and a little smaller and a little smaller. And they're actually getting closer and closer to 0. But you'll notice that it's never actually going to get 0. I can make you watch this video of me pushing a down button forever and ever and ever and ever. And this thing is never actually going to get 0. It's going to do something called getting infinitely close to 0 without actually touching it. It's like the most frustrating thing mathematically for these poor numbers, right? They can never actually hit 0. Okay? If I do that in the negative direction, so let me start over at 0. if I go in the negative direction with my x's, you'll notice that they're actually getting a little bit bigger because remember that the negative numbers work backwards. So like for example, 0.15 is actually a little bit bigger than negative 0.17, okay? So these are actually getting bigger, but they're still approaching zero, right? They're getting closer and closer to zero just from the other side, but it's never going to hit zero. And that's what this means when I say, y is closer to zero or y is approaching zero, okay? So that's what I mean by limits. And now you should be able to apply that same concept to all of the other graphs we've talked about, okay? As x goes to infinity, as x goes to negative infinity, what's happening? And remember, me saying x goes to infinity and x goes to negative infinity, fancy way of saying right and left. Let's maybe talk through one more. And if you feel like you got it, you can go ahead and shut this video off right now. But find some blank spots here. Okay, let's do a parabola. And just for fun, let's do an upside down parabola. Okay, so on this graph, when I say when x approaches infinity, what's happening to y, okay, I'm saying as I move to the right on my graph, where are my y values going? So the farther I go to the right, what's happening here? These are going down forever, not down to zero and stopping, down forever. That would be negative infinity. Okay, this down here is negative infinity. As I go towards negative infinity on the x-axis, which is to the left, this way, my y values are still going down forever, right? So even though I've switched directions, my y values are going down forever no matter what here. So I would say y is approaching negative infinity as well. Okay, so if you want to see all of the limit type answers for all of the different functions we looked at, I would double check that table that we filled out, and I did put a completed version of that table in your Google Classroom account, so you can scroll back and look at that. I would not try to memorize those because there's so many things that look so similar. Memorizing is not the way to go for that, okay? I would take the time to understand what I just did, and then if you've got a picture in front of you, you should be able to say to yourself, okay, as I go to the right, is my graph going up forever, down forever, or closing in on the middle, pinching in towards the middle? Those are your three choices, okay? And that's it for limits. That's the questions I'm really asking you there. So hopefully that helped before you take your quiz, and I will see you in class the next in-class day.